بسم الله الرحمن الرحيم. اليوم إن شاء الله إحنا نكمل عن Gauss-Seidel load flow method، اختصارها GS. If you remember بالlast lecture we derived the Gauss-Seidel load flow equation at each bus. طبعا this equation is valid for all buses except the reference bus. Last time we derived VI for iteration k plus 1 equals 1 على YII. نفتح قوس net injected complex power conjugate for iteration k مقسومة على VI conjugate of iteration A minus summation from J تساوي 1 J لا تساوي I for number of buses Yij Vj of iteration k. The problem is how to find Si or Si conjugate of iteration k. This is the only difficulty we may face in Gauss-Seidel load flow method. How to find Si conjugate of iteration k. The calculation of Si depends on the type of bus. We will notice that in Si conjugate of iteration k is a fixed amount, fixed number, I mean constant, does not vary with iterations. It's fixed for all non-generator buses, I mean for load buses. And we will notice also that Si of iteration k conjugate is not fixed. Not fixed, I mean it's a variable. That happens for generator buses. This is the only difficulty we will face. How to find Si for generator buses. We have 4 possibilities of buses. The first possibility, if bus I has no load, no generator. يعني بمعنى إنه bus I is a passive bus. In this case, bus I has no generator, no load. SGI equals 0 plus J0. And S demand at bus I equals 0 plus J0. In this case, net injected complex power is SGI minus S demand I. For SGI 0 plus J0 minus SDI 0 plus J0. The net is 0, which means Si in the equation equals 0, fixed, does not vary with iteration, as mentioned here. So this equation for bus I, for this type of buses, Vi of k plus 1 1 على Yii multiply, this is 0, divided by Vi conjugate of k, then this will be 0, minus Yij Vj. The only thing I want you to remember is that bus J should not equal to bus I, because when J تساوي I هي العلاقة اللي استخدمناها to derive Gauss-Seidel load flow equation. The second case, if bus I has a load but no generator, like this case. In this case, SGI تساوي 0 plus J0. And S demand I is B demand I plus JQ demand I. In this case, both values are fixed numbers, known. And also, these are knowns, 0, 0. In this case, net injected power is S generated minus S demanded at bus I. 0 plus J0 minus B demand I plus JQ demand I. Now, the conjugate of this SI, you replace the minus sign by plus sign. So it becomes SI B demand minus B demand I, and the conjugate of this one is plus JQDI. Notice also this is known and this is known, so the net injected complex power at bus I is a fixed number. I mean, it does not vary with iterations. In this case, when bus I has a load and no generator, Gauss-Seidel load flow equation at this bus I is given by this equation. So this is fixed number, does not vary with iteration. So this case is the same as the previous case. For case 3, if a bus I has a load and a capacitor, as you know, capacitor produces reactive power and it produces QCI. In this case, SGen is like this case. SGI, complex power generator, is 0 real power plus JQCI. And S demand I, these are given numbers, fixed. So when you find net complex power at bus I, S generated at bus I minus S demand at bus I. So if you put these values in this equation, you will get SI تساوي minus BDI plus QCI minus QDI. And the conjugate of this complex power is as shown. So this is known number, this is known number, and this is known number. So SI conjugate of iteration K is fixed also, which means does not change or vary with iterations. In this case, إذا عوضنا مكان SI complex conjugate in this equation, this is known, these are also fixed. So this quantity does not vary with iteration. This is the same as the previous two cases. So in all of the above three cases, SI conjugate of K is fixed number. So there is no difficulty in any of the previous three cases. Now, when it comes to the fourth case, if a bus I has a generator, such as this case or this case. As you know, for generator, real power produced is known, while reactive power generated is not known. The same is here. For both cases, real power is known, reactive power is not known. As you notice here, S demand is 0 plus J0. So this, in this case, S demand at bus I equals to 0 plus J0. So this is known. In this case, S demand at bus I, non-zero values, but are also known. For the both cases, SGI for the first case, BGI plus JQGI. And S demand I, as we mentioned, 0 plus J0. So the net injected complex power at bus I is SGI minus S demand I. So this is the net complex injected power at bus I. BGI plus JQI. Here, as we notice, BGI is known, QGI is not known. So BGI, which is the same as PI, this is also the same as PI plus JQI. Net injected real power at bus I is known, but this is not known. So SI conjugate is BGI minus JQI. If you put the counter K, it will appear here on QI. So we notice here real part of net injected complex power is known, but the reactive power, net injected reactive power at bus I is not known. Not known means this value changes with iterations. So you have to calculate QI for each iteration. The same is for this case. The only difference here, we have demand fixed values. SGI plus BGI plus JQGI. S demand I equals to B demand I plus JQ demand I. إذا عوضنا هاي الفاليوز بالSI، SI تساوي SGI minus S demand I. So you will obtain the result. This is known, this is known. QGI is not known here. Is not known, but QDI is known. So the net result that QI is not known. So as you know, the difference, this difference is PI, and this is a QI. This is fixed, known, but this is not known as a fixed number. But you can calculate QI in every iteration K. So in conclusion, if bus I has a generator, then QI of iteration K is not known, but should be calculated in each iteration using the equation we derived previously in the course. Probably in the last class, or the maybe one class before the last class. So as I mentioned in the class, you have to memorize this equation. When this equation is used, this equation should be used to find a QI in Gauss-Seidel when bus I is a generator bus. I mean a bus that has at least one generator.